Go Math Lesson 5-4. Today we're talking about ratio reasoning and applying percents to solve problems. So we have two ways that we're going to go about this. So one thing we already know of a percent is that a percent literally means out of 100. So if we had something like there were 80 students and 20% wore blue, right? And we want to know what percentage of students are wearing blue. Well, we can set that up as a ratio, use ratio reasoning. So I need 20%, 20 out of 100 is equal to how many out of 80? All right, so from there, I could cross multiply and then divide, or I could go down to a unit rate. And when I simplify, I'm going to find that this could actually come down to 1/5. When I simplify here, I'm going to divide by 20, divide by 20. And then how do I go from 5 to 80? I'm going to multiply by 16 times 16. So I end up with 16 out of 80 students wore blue. So that's one way I can do it. The other way I can do it is I know that every percent can easily be turned into a decimal. So if I'm taking my 16/80ths, and I'm going to leave that right there, but I'll erase all of this. Just give me a second to erase here. Boop. All right, so if I have 80 students, and I want to know what 20% of 80 is, well, I know that of means multiplication. So if I had 20%, 80 times 20%. Well, I don't easily know how to multiply percent, but I can multiply a decimal. So if we took this decimal, we realized that turning a percent into a decimal means that we're going to divide by 100, which makes this 20 hundredths, right? 20%, 20 over 100, 20 hundredths. We move our decimal two places. So again, turning my percent into a decimal, now I can multiply. When I multiply, it's 0 times 0, 0 times 8. I put down my placeholder because I'm multiplying by a tens unit. 2 times 0 and 2 times 8. When I add them all up, I get 2 digits to the right of a decimal in my problem, so I'm going to have 2 in my answer, and I get 16. You can see that I have 16 out of 80 students. So again, applying a percent can either be done as a ratio or it can be done as a decimal in a multiplication problem. So let's take another one. Typical family of 4 uses about 400 gallons of water each day. 30% of this water is for outdoor activities such as gardening. How many gallons of water does a typical family of 4 use each day for outdoor activities? So I'm looking for 30% of 400. So I can go, all right, 30, if I'm using my ratio reasoning, 30%, percent literally means out of 100, you're going to hear it in your sleep. 30% equals what out of 400 gallons of water? Well, that's easy enough. 100 times 4 is 400, and 30 times 4 is 120. That's 120 out of 400, which would equal 120 gallons right there. If I didn't want to use ratio reasoning, and instead, let's try it as a decimal, I would find that 30% of 400. And I would make it a division problem, or a multiplication problem, excuse me. But knowing that my multiplication is a decimal, not a percent. So my 30% is actually 30 hundredths. So I've moved my decimal 2 places because I'm dividing by 100. Decimal goes 2 places to the left. In this case, 0 times 0 times 0 times 4, and then I'm moving over 1 place, so I have a placeholder here, 3 times 0, 3 times 0, 3 times 4, 0, 0, 0, 2, 1. And we know that 12,000 is not the answer, but I know I have 2 digits to the right of a decimal in my problem, so I'm going to have 2 in my answer, and I get 120. You can see I have 120 either way. Whether I'm treating my percent as a ratio or a fraction and finding my equivalent, or I'm treating it as a decimal and just multiplying, I can get the same answer.